Mr. Wertz here, back with another Algebra 2 video. This time we're taking on graphing linear equations. So in this video, guys, we're going over how to graph linear equations that are both in standard and slope-intercept form because they model lots of real-life important concepts. And you'll know you can do this successfully when you can model something like 4x minus y equals 2 on a coordinate grid, and then you can accurately draw it and describe its features. So I'm just going to review some of the concepts for a linear equation. So it's important to remember that slope is a measure of the steepness of a linear equation. It's also called the rate of change, and is defined as being m in the slope-intercept form. It also indicates if the line is slanted up, positive, or slanted down, negative, from left to right. So you can see my two examples here. Green would be considered a positive slope, and red would be considered a negative slope. So if you want to calculate slope, and you're given 2 points, you can calculate the slope between them. You do so using the slope formula, which you commonly know as rise over run. Rise over run, actually, as a mathematical formula, is the equivalent of saying the change in y over the change in x, and you would calculate the change in y by subtracting the two y coordinates of the coordinates, and then you would subtract the two x coordinates of the coordinates, and you will divide those amounts. If you get a fraction, you want to reduce the fraction. Otherwise, do not turn it into a decimal. Fractions are what you should use for your slope-intercept form equations. And then just remember that parallel lines have the same slope. So if you are ever talking about two lines that have the same slope, remember they are parallel. And that's going to be important information in the coming unit. So the other thing we're going to talk about is the intercepts. Remember that the intercepts represent the coordinate locations of where a linear equation crosses the y-axis, called the y-intercept, and the x-axis, called the x-intercept. The y-intercept always has an x-coordinate of 0, and the x-intercept always has a y-coordinate of 0. So take a look at the graph here. The y-intercept here is 0, 4, and the x-intercept is 5, 0. So remember that the y-intercept needs to have an x-coordinate of 0. So in my this coordinate space here, I would write 0, 4. 0, 4. And to represent the x-intercept here would be 5, 0. Okay? So please make sure and remember that the y-intercept needs to have an x-coordinate of 0, and the x-intercept has a y-coordinate of 0. So it's like flip-flopped. Just keep that in mind. So we're going to jump right into graphing linear equations slope-intercept form. So the preferred method for doing this is using your technology to assist you. So I am going to give you a second to copy down that equation. And I'm going to switch to having my on-screen calculator here. This is my phone using the Calculate 84 app. You can go get that in the Apple Store, or you can go get it on the Google Play Store. I think it's fantastic, and everyone has access to it. So I had an equation in there. I'm going to clear it out. And the equation is negative. So I'm going to use the minus sign down here. 1 divided by 5 x plus 8. So notice that I used parentheses to enclose my fraction. I used the x coordinate, or the x variable, and I used the positive 8 plus 8 on the end. Do not use the minus sign, so don't use the minus sign here. You need to use the negative sign to create negative numbers. The minus sign is only for when you mean to subtract something. So I'm going to go to graph, and I'm going to see this. So my graph on here goes from 0 to 10, just like the one graph that I have on the screen here. So what I'm going to do is switch from second. So I have an idea of what my graph should look like. Now I'm going to switch to second table, and I've got coordinates here. I can see lots of them are decimals. Rather than estimate decimals, I'm going to start from the leftmost point of my viewing window, and I'm going to graph every whole number. So negative 10, 10 is up here. The next one, and now that I'm working back in my notebook, you're not going to be able to see my software, or the phone software, but that's okay. The next one is negative 5 and 9. The next one after that is 0, 8. And there's the y-intercept that is represented in the equation here. Remember, this is 0, 8 for my y-intercept. And I just plotted that on the graph. The next whole number is 5, 7. And the next whole number then is 10, 6. So there are the series of dots, the series of coordinates that allow me to take a line. And I'm just going to use the black line here. I want to be as precise as possible. And trying to sketch it by hand is not going to be precise for me. So then I'm going to just attach arrows on the end. And the reason that we're doing this is very important. That's because the domain of this graph is negative infinity to infinity, meaning it goes on for forever. So you need arrows on the end. And the arrows also slant up and down, so that means that the range is also negative infinity to infinity. So it is very, very important for you guys to make sure that you attach arrows to the ends of your graph. Because despite the fact that it quote-unquote goes off the graph, it doesn't really. It's just outside of the viewing window. So we're only looking at a very small portion of the graph. We're not actually seeing the entire thing. That said, this is a negative slope. So just defining some other features here. This is a negative slope. And the negative slope is represented by the negative 1 here. So there's some good pieces of information. So you can also see, let me backtrack just 1 second. You can also see that the negative 1 over 5 is represented by descending 1 on the graph as I move to the right. And then I move right 5 spaces. In that same time that I descend 1, I move 5 to get to the next coordinate. So let's move on to the next one. So this is a slightly bit different, okay? It says, graph the linear equation that lies on the coordinates 3, negative 3, and 6, negative 1. Don't forget to find its intercept as well. Okay, so I don't even have a line. All I know is that y equals m times x plus b. So what if I see a problem like this, I'm like, well, I need to write an equation to graph it. So what I am going to do is use these coordinates, and I'm going to graph them at least, because I know that they are on the line. So 3, negative 3 is here. And then 6, negative 1 is here. So I have 2 lines, or 2 points between them. There's 2 ways that I can calculate slope. So I am going to show you the slope formula because I do want you to be able to calculate that. We're going to subtract the y's, and we're going to divide that by the same thing with the x's, x minus x. In this situation, what I am going to do is substitute values. So here's y, and this is a y. These are x's. So I'm going to start with the doesn't matter what order I do them in as long as I'm consistent. So I'm going to do negative 3 for this y coordinate, take away negative 1. Okay, remember that it's always minus between the two. So I'm going to use parentheses to show what I substituted in. I substituted negative 3 and I substituted negative 1. I didn't add any additional negative signs. The original negative sign here is the same as these, as it is in the rewritten equation with substituted values. So then the x coordinate, since I used negative 3 first, I need to use the corresponding x coordinate first, 3. And then I need to use the corresponding x coordinate in the second one, 6. So now what I am going to do is I am going to simplify. So negative 3 take away negative 6 or negative 1 is going to be saying negative 3 plus 1. And that's going to give me negative 2. And actually, you know what? I don't want to write it there. We're going to write it down here. So I have a little bit more space. And then 3 take away 6 is negative 3. Well, when you get a double negative for slopes, that's okay. Double negatives just turn positive. So the slope would be written as m equals 2/3. So I can now substitute this value in here, in my equation. So I get y equals 2/3 x plus b. But in order to put it into my graphing calculator, I still have to go back and find b. So to do so, what I'm going to do is I'm going to steal one of these coordinates here, and I'm going to evaluate this equation using these coordinates. So remember section 1.4 when we did our evaluation? Well, that skill's coming back into play. I'm going to steal this coordinate here. You can pick either coordinate. It doesn't matter. I just choose to take this one for now. And I'm going to substitute the -1 in for y. I'm going to evaluate it for that. And I'm going to evaluate when x is 6. So plus b, that is a 6. Not a great looking 6. Let me fix it. Let me fix it. So what we're going to do next then is I'm going to multiply out over here, and in order to find b, I'm going to try to get it all by itself. So b here, in order to actually find b, I need to get it all by its lonesome self. So if I multiply 2/3 times 6, I do that on my calculator, so 2 divided by 3 times 6, I get 4. So I get 4 here, plus b equals -1. So if I'm going to solve for b, you guys should know the drill here. I'm going to subtract 4 from this side to remove it, and then I do the same thing over here to make sure that I keep my equations balanced. And then I get b is equal to -5. So that means that, so b is -5. I'm going to be able to substitute that value up here, technically in here, for my equation. So I'm going to draw this down here and say y equals, so it's 2/3x, and then because b is negative, I'm going to use a minus sign, -5. So now I have the equation that I need to graph in order to complete the rest of the coordinates on this graph. So I'm going to switch to my graphing calculator. I'm going to go over to y equals again. And to put in my fraction, I'm going to type 2 divided by 3 in parentheses, x minus 5, and hit graph. So I see my coordinates kind of look like they're on this graph. But in order to get the rest of them, I'm going to go into the second graph button, which takes me to the table. And I'm going to graph all the whole number coordinates that I have. So I'm going to go back to -10, because that's the lowest value that I have. And -10 is a decimal. So I'm going to pause. And then I'm going to go to -9. -9 is down at -11. It's outside of my viewing window. So I'm going to actually proceed to the next one. The next one is at -6 and -9. So here's the first coordinate that is inside of my viewing window. Then I'm just going to continue. -3 and -7. Yep, -3 and -7. Oh, hang on. I think there's -7. Yep, I mispositioned the dot. Excuse me, guys. The 6 should be over here. I mispositioned the original dot of -6, -9. And then here's our y-intercept, 0, 5. And then if I scroll down all the way to the bottom, 9, 1 is here. So sorry about that pause, but I was just trying to line up with my eyes if I put my coordinates correctly. So I'm going to go ahead and take my line tool because I want to be precise, as precise as possible. And I have to adjust it because I didn't do it quite right. And arrows on the end. So the domain of this is still negative infinity to infinity. And the range is also negative infinity to infinity. And there is that equation. So we're going to move on to the next one. And it's when we graph from standard form. So remember the conversion skills, guys? We just were practicing our conversion skills of taking standard form and moving into slope-intercept form. Well, now is the time to use it. We're going to convert the standard form first, then use the graphing calculator to graph the line. So the first example gives me 6x minus 4 form. Our slope-intercept form is to have y equals m times x plus b. Y should be by itself with no coefficients. So right now, we have 6x on the same side as y. So that's problem number 1. And to fix that, I'm going to remove 6x from this side. But in algebra, we have to keep our equations balanced by doing the same thing on both sides. So I get negative 4y equals 16 minus 6x. Now, I'm almost there, but the problem is I have a negative 4 as a coefficient for my y, but I can't have any coefficients. So what I'm going to do is divide both sides by negative 4. And what that does is it reduces the coefficient from negative 4 down to 1 because these amounts are opposite. So I get a y over here. The 16 divided by negative 4 is going to be negative 4. And then negative 6 divided by negative 4. So I'm talking specifically about this part right here. Negative 6x over negative 4. We do know it's going to turn positive. And then negative 6 divided by negative 4, both of those numbers are even, which means I can divide them by 2. So if I divide the top by 2 and the bottom by 2, I'm going to get 3 over 2. Negative 3 over negative 2, and then we know that a negative divided by a negative is positive. So I'm going to get plus 3 over 2x. And then just for clarity's sake, this is totally fine. Y equals negative 4 plus 3 halves x. I'm going to flip-flop these. And I'm going to take all of the negative 4 with me, okay? So it becomes y equals 3 over 2x minus 4. So if I go ahead and plug that into my calculator, so I'm going to swap to my calculator screen here. Y equals 3 divided by 2x minus 4. I hit graph, and it looks like that. So I'm going to go into my table and go all the way down to negative 10. Well, negative 10 is at negative 19, which is far outside of our viewing window. So I'm going to try negative. The next whole number is at negative 8, and that number is also outside of our viewing window, negative 16, so I'm going to proceed. Negative 6 is also outside our viewing window. Negative 4 is the first coordinate where the line appears inside of our viewing window. So negative 4 and negative 10, negative 4, comma, negative 10 is the first coordinate that appears on on this graph, the viewing window. The next one is negative 2, comma, negative 7. And then we encounter the y-intercept, 0, negative 4. And we should, because that's exactly what we put into the equation. And then the next one is at 2 and negative 1. The next one is at 4 and 2. 6, 5. 8, 8. and the next one goes outside of our viewing window at 10 and 11. So since it's off of the viewing window, we're not going to try to graph it because we can't see it. So there's my line. Putting arrows on the end because, once again, the domain of this linear equation is negative infinity to infinity. And the range of this equation, this linear equation, is also negative infinity to infinity. Just a heads up for you guys, the domain and range of all linear equations is always negative infinity to infinity. Same with the range. So I have one more for you guys, and that's the one that I said if you can do this, then you're understanding what I'm trying to teach you here. Graph the linear equation in standard form. So what I'm going to do is hope that you can go ahead and pause the video and then attempt to do this on your own and then come back and watch for feedback. But I am going to just go through it, so if you're right, we're going to do that, pause now. And if you did it correctly, you'll be good to go. And so, pause, and I'm going to do the answer now. So, graph the linear equation in standard form. I'm going to go ahead and, again, remember that my goal is to get y equals m times x plus b, meaning y is by itself. So that's my goal. Well, y is not by itself. And I can fix that by removing 4x from this side, but I must balance my equation by doing the same thing over here. So I get negative y equals 2 minus 4x. Now, I'm really close, okay? I see that it says negative y equals 2 minus 4x, but the goal is supposed to be y equals mx plus b. Well, this is a positive y, and what I have is negative y. I remember that I can multiply stuff by negative 1, and it flips the sign, it changes it to a positive, but it doesn't change the value. So I'm going to go ahead and do that. I'm going to multiply this side by negative 1. I'm going to multiply everything over here by negative 1. So I get y is equal to negative 2 plus 4x. And if you'd like, you can go ahead and change that. Flip these around. So this is going to go here, and we're going to take all of this and flip it here. So I get y is equal to 4x minus 2. So I'm going to go ahead and plug that into my calculator. So I'm going to flop to my calculator here. I get 4x minus 2. Goes in like that. I'm going to hit graph. And I can see that this is a pretty steep graph. So I'm going to go into my table here and start all the way down at negative 10. Because that's where my viewing window begins. Like this point over here, this edge of the graph is at negative 10. I see it's all the way down at negative 42. Well, that's way outside my viewing window, so I'm going to just keep going. I can see my coordinates are rising, but still not on the window. Negative 2, 10. Negative 2, negative 10. That's the first one that we can see. Negative 2, 10 is the first point we can see. And then we have negative 1, negative 6. We have 0, negative 2. We have 1, 2. Sorry, I stuttered there. We have 2, 6. And we have 3, 10. And then, boom, it's off the graph. It's out of our viewing window again. So off the graph is kind of like old, the old way to think about it. How I want you to think about it is it's outside of our viewing window. So now on the end of my linear equation go these arrows to represent that, again, the domain is negative infinity to infinity. Left, right, and the range, the up, down, is also negative infinity to infinity. So that's it, guys. Today we discovered the slope of a line and how it slants the line, as well as how to calculate the slope between 2 points. We learned the difference between the Y-intercept and the X-intercept and where to find them on the graph. Remember that the intercept of slope-intercept form always refers to the Y-intercept. We graphed linear equations in slope-intercept form, including when we were only given the slope. and we graph linear equations in standard form by converting them to slope-intercept first. So that's it for the video, guys. Thanks for watching, and I will see you in the next one.